Hello everyone out there. Thank you very much for watching my video today on matrices, determinants, the identities, and the inverse of a matrix. Let's start with talking about inverses again. We've already a little bit talked about this in previous videos, but inverses take something and bring it back to the identity. Think about real numbers again, like we've talked about previously. What is the additive inverse of 7? Okay, so the additive inverse of 7 would be -7. Why? Because 7 plus -7 would equal 0. And 0 is the inverse, is the identity for addition. What is the multiplicative inverse of 7? Okay, well, the multiplication identity is 1, so we want that to be 1/7. Why? Because 7 times 1/7 is 1. What is the additive inverse of x? Well, that would be -x for the same reason as above. What is the multiplicative inverse of x? So that's 1/x for the same reasons as above. With functions, the identity is x. Let's look at one here, where f of x is 3x plus 7. Let's find the inverse of it. All right, so remember for the inverse, we switch our variables, and we solve. So there's our inverse. What would you get if you composed f of f inverse? So if we put f inverse what will we get back? So f of x minus 7 over 3 equals that. Okay, so the 3 over 3 would cancel. That'll leave me with x minus 7 plus 7, which is x. Okay, what about f inverse of f? So f inverse of f. So that would be 3x plus 7 minus 7 over 3. Which is 3x over 3, which is x. Look at that. We learned that in units past, that a composition of a function and its inverse will always lead us to x. So now let's jump into matrices. Inverses of matrices are more difficult to find than regular numbers, but the idea is still the same. Let's multiply these out and see what we notice. All right. So 2 by 2 times 2 by 2, we're going to get a 2 by 2 back. That would be -1 plus 2, 2 minus 2, -1 plus 1, and 2 minus 1, which is 1, 0, 0, 1. Okay, 3 by 3 and 3 by 3 will give us a 3 by 3 back. So we're going to get -2 plus 3 plus 0. -2 plus 3. Oops, that's not right. Sorry about that. It'd be -3 plus 3 plus 0. 1 minus 1 plus 0. All right, second row, -2 plus 0 plus 2, -3 plus 0 plus 4, and 1 plus 0 minus 1. Third row, -12 plus 6 plus 6, -18 plus 6 plus 12, 6 minus 2 minus 3. Simplifying, 1, 0, 0, 0, 1, 0, 0, 0, 1. So both of our operations here, that's wrong, sorry. I said 0 and I wrote 1. Both of our operations here got us back to the identity matrix, where 1s are on the diagonals and 0s are everything else. Right? The matrix I is an identity matrix, and is the equivalent of the number 1 in scalar multiplication. So these are basically like 1 in regular multiplication. Associated with each square matrix is the real number called the determinant. So sometimes you see it written like this, determinant of that, but often it's just straight bars, A, B, C, D. To find the determinant, it's really easy. You just do AD minus BC. So first one here, it's going to be 5 minus 6, or negative 1. So the determinant of that matrix is negative 1. Second one, negative 5 minus negative 12, or negative 5 plus 12, which is 7. Why is the determinant important? It'll show itself in a few slides. First, let's talk about the determinant of a 3 by 3. This one's much more complicated, but still very doable. What I like to do here is I like to take the first two columns and copy them and put them outside the matrix. And then diagonally we multiply and then add those together. And then diagonally we multiply and add those together. And then we subtract the red minus the blue. So here's how it works. Copy these down here. And then 4 times 1 times 5 is 20, plus 2 times 0 times 2, plus negative 1 times negative 3. Minus, now we go backwards diagonals, so these 3 diagonals here. 2 times 1 times negative 1, plus negative 3 times 0 times 4, plus 5 times 1 times 2. So it'd be 23 minus 8, or 15. Next one. So again, we're looking at these diagonals. First. So that would be 0 plus 0 plus 32 minus those diagonals. So that would be negative 24 plus 0 plus 0. So 32 plus 24 is 56. So why is the determinant important? Well, that's going to be how we find an inverse of a matrix. In scalar algebra, we know that A times 1 over A equals A times A inverse equals A inverse times A equals 1, provided that A isn't 0. We call A inverse the multiplicative inverse of A. For square matrices, and it's only for square matrices, 2 by 2, 3 by 3, 4 by 4, whatever, we define the inverse A inverse as having the property A times A inverse equals A inverse times A equals I, the identity matrix. So if A equals A, B, C, D, to find the inverse matrix, you find the determinant, take its reciprocal, and multiply it by this matrix here. So you flip A and D with each other, you switch them, and then you take the opposites of B and C. A inverse cannot be found by rearrangement because division is not defined for matrices. A matrix has no inverse if determinant is 0. A inverse, if it exists, is unique. So here's an example of finding an inverse. You can check that out if you need to on your own time here. Let's jump right into the first problem. So let's try to find the inverse of that matrix. All right, first let's find the determinant. So determinant of that would be 8 minus 9, or negative 1. All right, so our inverse matrix then is going to be 1 over negative 1, which of course is negative 1, but we'll leave that there for now. You switch A and D, you take the opposite of B and C. So our inverse matrix is negative 4, negative 3, negative 3, negative 2. All right. To check it to make sure, you simply multiply by the original matrix times our inverse matrix. And you should get this. And then you do the same thing, except you do inverse times our original, and you should again get the same thing. All right, you should get the identity matrix both ways. All right, let's take a look at one more. So first, let's find the determinant. So determinant of 4, 2, 10, 5 here is 20 minus 20, which is 0. Since the determinant is 0, that means this one has no inverse matrix. Okay? That's it for the lesson part of this video. The last 3 slides are some mixed practice. You can try those practice problems on your own, and then you can check back at the end of the video when you're ready. But go ahead and pause the video right now. When you're done with all 3 slides, check back and see how you did. Here are the first 6 problems, first 6 answers. I want to focus here on F for a second. If you're trying to find the determinant of this, you just got to be careful with multiplication and addition. I want to really zoom in on that so you can see that there. Okay. But now let's go on to the next page. 7 and 8. And the last 2, 9 and 10. Or 9A and B, I guess, would be a better way of saying that. All right, thank you as always for watching my video today. Hope to see you again soon.